DevOps, network runner, now business nerd, formerly technology nerd, running a company called Kentik, and we help people with the network analytics piece, which is missing from a lot of infrastructure. I'm going to credit our CTO, who knows Roy from Netflix, who's in the back row, for this next slide. How many people have a Star Trek knock anywhere in their infrastructure? At Akamai, I was at Akamai for 10 years. I started in ISP in 1992, and I was at Akamai for 10 years, so a lot of experience with that. So lots of different kinds of tools. I'm just going to ask very quickly, how many people have some sort of ping trace route tool? Configuration management, metrics, logs, API, something for NetFlow? People's hands go up. Routing analytics, HTTP, DGB, SIM type, security forensics tool. Threat intelligence somewhere in the enterprise. DP hijacking, DDoS. So a lot of different kinds of tools. And fundamentally, the question is, how do you know if there's a problem? Right? Because when you take one of these domains by themselves, oh, there was a fart in the network. Did anyone notice? I pinged something in South Africa, it didn't work. Well, do I have any traffic there? The APM says it's not a problem. Well, is there a problem in the network, or is it a server problem? Now the APM and now the APM vendors are doing at least metrics. Some of the metrics folks are doing distributed tracing. A lot of that is coming together, but we see a lot of the network side missing. And there are a few different reasons for that. We actually think that it's healthy if you don't hear, is it the network? If the people that run servers, applications, and even the business side can know if there's a network problem. And the people we deal with, who are mostly web companies, service providers, infrastructure providers, they actually want the other groups to know. They're not trying to hide this data. They're just, if you try to give someone, how many people use Cacti? And there's one, MRTG still? Anyone MRTG? One. So, like a lot of these tools, you give them to a sysadmin or a DevOps person or whatever the politically correct SRE, and they just go, what is this and why can't I double click? So that's a problem. But what's interesting is the network actually knows a lot of different information because the applications generate the traffic, but it ultimately has to be delivered over the network. Now for old people like me who think NetFlow is just some packets and bytes went from this IP address and port to that, there's a lot of interesting stuff that can be done, but I'll talk briefly, because I only have 20 minutes, about there's actually some other interesting network layer information you can get that will show you performance of the network and also of the application, which I think is a missing part of a lot of what people do with APM. And a lot of your current tools show you what should be, right? It's what's specified, what's authorized, what's coming from the web servers. But when you get into attacks, which are really more of an availability thing, like in DDoS, a lot of that traffic is not going to come from your web servers because it's someone probing different parts of your network, and again, the network sees that. So we think it's an important part of bringing into infrastructure. So how many people have ever configured a router or switch? Okay, how many people have ever turned on NetFlow? And how many people have spent 3 frustrated evenings cursing at NetFlow, open source NetFlow tools? Okay, so.
We just never looked at it again. It's easier that way.
Okay, you just sent it somewhere and never looked at it? Okay. You just keep Google and you keep looking at tools. And so NetFlow is a summary, you could use the Snowden term, metadata of the traffic. It's a summary of the summary. It's a summary of the headers of the traffic. So for pure NetFlow and for IPFix, there's no actual packet data that goes over. It's the router observes, and there's 2 ways. It could be a sample of the headers or a sample of the flows. And a flow is a bunch of packets that went to and from the same place. It's called a 5-tuple. Protocol, and then source IP and dest IP, and source port and dest port. So when that goes, when there's a communication there, that's a flow. And what we're trying to ultimately do is get summaries of that data and then store it and be able to query it. And the problem is it's always been a big data problem. It required distributed systems, and basically a lot of times the distributed systems, the developers, and the network operators don't talk to each other. So these are generatable by your switches and routers. If you have a Cisco, Brocade, Arista, Juniper, Cumulus, whatever, server, you can generate this data. The question is what you do with it, and I'll show you a couple quick ways that you can deal with it. Of course, there's also other kinds of network data. There's SNMP, which we all don't love. There's streaming telemetry, which is the idea that routers will push all that stuff at your metric system, which will be thrilled to ingest 100 million metrics from every router about every fan and route and everything. And logs, which can be useful. Routes went up and down, interfaces went up and down, optics are failing. That stuff is useful too. And then configs and topology and other stuff. So the awesome news as a vendor is there's a shit ton of work to do for decades still to integrate all this stuff from the applications and the servers and the network and the config. But we're just trying to get started in basic places. Now, for the network nerds, there's actually a lot of different things which are very network specific that get done, and some that start bleeding. So some things like customer cost, maybe Fastmetrics cares about how much does this customer cost me, how much transit, how much international, I'm going to grow your network down. When they want to renew, that's a business use case actually. Maybe an enterprise wants to know what's their security posture, and the folks that actually run the infrastructure want to know what are my infected machines. So you take threat feeds and combine them with NetFlow and do that. And network people are just beginning to learn you can actually get performance data about it. But so we generally start when we work with network people who've been struggling with the network problem, but it doesn't have to just be for network people, because we think that it's all three of those things. It's the application, the servers, and the network all have to collaborate, and you've had problems, I assume, you've had problems in some of all those things, and they happen. So how do you combine that together? How do you tie them together? One way is you can actually make flow look like metrics, which I'll show you briefly. We actually have a Grafana plugin that we paid them to do, which talks to our backend, which is a column store that makes it look like metrics. How many people have tried to take NetFlow, summarize it, and stick it in a time series database? Okay, so what happens if you do that with protocols, it's fine, because there's only 255 values. If you do it with IP addresses, and you have 10 million different values in a time series database over 90 days, and you ask it to give you the top end, they're really not designed to do that. But yet there are some things which at least you can do, some of the protocol attributes which you can do well. And then the other is have a flow system that actually can expose APIs and let people use it. And really one thing the whole world of flow tools needs to do is get easier to use for people that don't know what the network is. So there's some open source tools. The deck will be up, distributed. Basically, none of them cluster. All of them, and we're talking about billions or trillions of records a day, even 1 in 10,000 samples, all of them store that on one computer. Or if you use Silk, which comes from the government, you can buy a warehouse-sized NFS filer and stick it on there, and then still take hours to run your queries. There are some people in the commercial space. We are one of them. There's Arbor, which is older appliance. And we see a lot of people using mostly Elastic, and sometimes some of the SQL Hadoop type things. The PM account to combine BGP and stuff, and that's a really hard problem. Even if your database doesn't understand what a prefix is or what BGP is, to combine it can be interesting. But the good news is NetFlow and all the related protocols are mostly UDP, or mostly sent as UDP. So it's actually pretty easy to copy, replicate. Modern, sometimes people send it in Kafka, but even just with something called Samplicator, send it to multiple places. It's very easy to experiment with. So what's so hard about it? To make full use of it, you need to combine geography, routing information, like what network did it come to and from, sometimes threat intelligence. What application is it? What user is it? What data center is it? That's not contained in the flow, so you need to fuse that. And it can just be very large scale, and as I mentioned, they don't cluster. So, possible to do it yourself, but it typically requires distributed systems, network engineering, SRE, and level, and people that know what a routing table is in a Patricia tree, and people that know how routers are configured. So the good news is there's some work in the area, and what I would say is, and the goal of this is, just to expose you a little bit to some of the things that you can see looking at the network tools, if that's not something that you've done, that you do or have done recently. And I would say it's better to get started, better to do something. And I'll show you even how to, if all you have is a metrics database, you can actually take data from flow, from PCAP, from watching packets from a server, and do something, put that into the system. Put that into your TSDB. You have to get the data. I mentioned Fusion, which is augmenting it, and there's PM account is the open source thing that people use for that. Storing it, which is a separate complexity, and then we really think sharing the data. How do you expose this to all the different systems? And I'm going to skip through quickly. I just do want to make one point again for people that are old network dinosaurs. NetFlow classically has meant this bytes and packets went from here to there. But if you get data from servers, or even from some network elements, you can look at retransmits, client latency, server latency. And this is what I think is really interesting to bring into the APM type view, which is, okay, there's a performance problem that's affecting users. Is it correlatable with a POP, a remote network, some part of the infrastructure, so that it doesn't become just a black box. And again, I'll show you briefly nprobe, which goes on servers. That same approach can be done with taps. How many people have any network taps in their infrastructure? So on. It's not a very modern DevOpsy thing to do. That's a more gigamod enterprise big thing to do. But there's even routers that can send this kind of data. So fusing, I mentioned briefly, and let's see. Hold on, I think I have a slide on the summaries. So the summary is, I think that where we should all be heading is application, server, and network data. I think there's problems that occur in all three of those things that can be interrelated. For network people, I would just say, look at some of the modern work that's being done, and when you hear NetFlow, don't just sort of tune that out as, oh, that's just for DDoS, or that's just for peering. How many people know what peering is? You know, identify people you connect to, said that's a lot of the use for this data. But again, maybe I want to see, am I having a latency problem to Twilio or Google Maps or whatever I depend on to deliver my service is not in my control. My APM is going to see this high latency, but how do I know if it's a network path problem or whether they're having a service problem? And really usable cross-group. So I'll show you a few different tools, a few different things. Let's see. How many people recognize, how many people use Grafana somewhere? Okay. Backends, let's talk Graphite with Whisper. People still do that? Okay, raising their hands. It's not quite as embarrassing as RDs, as using MR2G anymore. Prometheus, who are fully cloud native. Oh, really? Not that many. Influx. Okay. MySQL as a time series backend. It's done. So a lot of our customers put application metrics in time series and view it through Grafana and use it to correlate with active measurements like ping and server metrics like IOPS and CPU and temperature and RAM and all that. So that looked like to us a good place because we didn't want to build a whole metric system. We leave it to people like David to be able to show some of the network data in. So we actually had Grafana build a plugin that uses our backend like it was a time series database, and actually work with them to add filtering, which is a new capability in Grafana, so you can add filters and say, show me something only for this. And that was important to them also because they're trying to replace the Kibana in the Elk stack for people that want to really open source contributory thing. So we can, the way that we've done it is we can select devices, so we can select all the network devices, or if people have certain devices because they're building a diagram for a dashboard for an application that only is affected by a certain part of the infrastructure. And then we can just say, what's the total traffic? That we can get from SNMP, so you don't need NetFlow for that. But the beauty of getting all this data, storing it, and chopping it up, and I would just say the way we do it is we do zero aggregates anywhere. So we actually just go from the raw flow records and build up, is you can pick dimensions, country, geo, IP. We actually let you do, how many people know what BGP AS path is? It's a description of the routing between two networks. So we can say what countries is the traffic going to. And now, if I had a big blip, and this were a little higher risk, I could correlate that with things in other domains. I actually heard a complaint from a mutual user of Grafana and Kentik earlier. They'd like Grafana's, I think, integrated communion. They'd like that alerting system to be able to correlate across domain. It's something I'll talk to them about. And but instead of that, we could look at even down to the IP address, look at traffic. So really some of the, I'd say the core thing is getting some static top end into your metrics database is at least a good starter of a double click on SNMP. Because SNMP will just show you there's this much traffic and you see a blip. What was it? Was it a misconfig? Was it an attack? And then ultimately, if you can really get flow analytics in there, you can group, you get yourself so you can group by any dimension, or you can also say, okay, show me that for country US, add a filter, and then it'll actually go rerun that, selecting out the records that are for the US, and then show you that data. So all this is ultimately doing is calling our backend via an API. But you could do a more limited version of the same thing with a time series system. The only thing I would caution you is, if you try to put values, which like IP addresses or even port numbers, that can range across 65,000 values over 90 days, you just want to be very careful before you go run a long time query in a time series database, because it may take a long time or actually crash it in some cases. We haven't tortured outlier with that yet, but maybe we should. Another thing I'll show you is, so if we get data from a server, and this is a server running, I won't even show you the uname. It's an older kernel, so there's a reporting bug on the Intel net. But it's running a couple, like 250 megabits per second of traffic. We have software called nprobe, which is from NTOP, if anyone's tried NTOP. NTOP is an aggregate-only backend for NetFlow, but nprobe actually generates NetFlow. And one thing nprobe can do is generate NetFlow with performance data, and I'll show you a little bit of that. So what nprobe is doing here, dreader-d, anyone know what Usenet is? Okay, so this is a Usenet server, and dreader-d is a Usenet daemon. So really old people, really old people. I told you, I started
What century is this?
What?
What century is this?
I started, yeah, so it turns out there are people that pay, and we don't talk, first rule, we don't talk about what's in Usenet. We look at the message IDs, so dreader-ds are running, those are the application, and nprobe is actually watching all the PCAP and generating flow. And that's interesting, but what's really interesting is that when we have data that comes from there, we can actually start to look at latency by country, latency by network, filter that again. If I populate and know what IP addresses or what application,
Yeah, years ago, last time I looked at libpcap and all of its attendants, it had a massive performance impact when you ran it. Has that been mitigated?
Well, you can't do that you can't, so the answer is no for PCAP, but there's actually a few workarounds. One, you can watch a 16th of the traffic. So on the servers, you can do, I'm blanking on the name, yes, Nick?
So let me clarify one thing. libpcap has at least gotten better where it doesn't impact server performance. It just doesn't give you all the data.
Right, you'll miss. It won't kill the server. Well, NetFlow used to kill
But there's a thing called RSS sharding on most of the
receive side scaling.
receive side scaling.
So you can.
So it's a sampling methodology.
It's a sampling methodology. But what's important is you actually want to flow sample, not packet sample. If you packet sample, you won't be able to track the sequence numbers across a session. How are we on time? 1 minute. Okay. And then post S-flow. Actually, on modern kernels, you can use BPF to do samples of packets, but get the TCP info struct, which has that data, instead of having to reconstruct it. So what I was going to show is, and actually when we loaded from the dashboard, it doesn't show that, but if you watch the packets from a server or from the infrastructure and get the data, now you can have the same kind of where the traffic will come from. Well, what's the actual performance? Take my word for it. If we had more time, I could show you. Break down per application, per server. And again, that's the kind of thing which is missing from APM. And while a lot of these tools, there's a very, very expensive $300,000 boxes you can buy that do the same thing, they will show you some of this and go a little bit up the app stack. None of them are true APM tools either. So ultimately, I think what should happen and what we're trying to make happen over the next years is, again, all these things, the metrics, the logs, the APM, distributed tracing as that comes out, and bring the network piece in. And happy to talk to people who are working on doing that themselves, Even if anyone's just wants to get that data into their tool, we have a PCAP generator that just sends top talkers data in graphite format, and you'll exploit your backend, but I'm happy to give you that code. And you know, Kentik, there's Tracealytics, there's some other services out there too. So just network nodes, it's valuable. It's a hard problem, but lots of people working on it. So.